The purpose of this video is to look at some strategies for finding limits. So let's look at this first one. This first one's very straightforward. There's really nothing unusual about this limit. It has it's a continuous function, and you're not dividing by anything, you're not taking any square roots or anything like that. So basically all you do in this case is you plug -4 straight in for x, find out what this is, and that's your limit. Here, we look at this and we see that we have a division here where we have a rational expression, but we also have an x squared here, so this will never become negative. And in this case, we're actually just plugging 6 in. So again, this is another direct substitution. Put in 6 in both of these situations. Here, looks like we could have a division by 0 if this was 1, but it's 4. So in this case, again, we could just plug 4 into both of these places and find out what the limit is. Here's our first slightly more complicated one. X is approaching -4, so -4 plus 4, you're dividing by 0. So what you need to do in this situation is factor this, and then if x plus 4 is a factor, this will divide out. And then whatever's left up in the numerator, you'll plug -4 in for and get your answer. And that's going to work out in this case. In this case, we have x is approaching 5, so you have 0 here in the denominator, and you also have 9, the square root of 9 is 3, 3 minus 3 is 0 over 0. That's one of the most common ones, where you need to do something to change the way this looks. And in this case, we can multiply by the conjugate. So what we can do here is just multiply this by square root of x plus 4 plus 3 divided by square root of x plus 4 plus 3. So basically by doing this, we're going to get rid of these square roots and end up with x plus 4, it's this times this, minus 9. And if you notice, that's going to be x minus 5, so that's going to cancel this out. And all we'd be left with is this in the denominator. And then we can stick 5 in here. Now we have a few limits with trig functions. If you remember, basically I have two very important limits, which are the limit as x approaches 0 of sine of x over x, that's equal to 1, and the limit as x approaches 0 of 1 minus cosine of x over x is equal to 0. So if we look at this one, this looks like very similar to this. And we can break this thing apart by thinking we have sine of x over x 3 times. Because if you think of sine to the 4th power, that's just sine times itself 4 times. We have that sine of x times sine of x over x. And then we have that 2 more times. Each of those is going to be 1. So we're going to be left with just the limit of sine of x as x approaches 0. And that is the sine of 0 is 0. So this limit turns out to be 0. If we look at this one, we have something similar. We have sine of x over x is 1. We have 1 minus cosine of x over x is 0. But then we still have 1 times 0 in the numerator, but we still have, this is x to the 8th. So an x was used for that to make it 1, and an x was used for this to make a 0, but we're still left with 2x to the 6. And if we think of that as x approaches 0, we're dividing by 0, so basically there is no limit here.